An investigation into the black swan phenomenon. The recent black swan, the horizon behind the oil platforms being promoted by Nathan Oakley and Quantum Eraser, inspired me to investigate this phenomenon. What is a black swan? A black swan is a photographic or observational evidence that shows the horizon behind an object that is beyond the physical geometric horizon of a sphere. The distances involved are based on a mathematical geometric calculation that uses the radius of the sphere and the observer's height. The calculation is an accepted and proven mathematical formula. If you are not familiar with the black swan phenomenon, then the above description might sound vague and unclear. A visual representation will now follow that will hopefully put the above description into a more understandable manner. A man standing on a sphere would observe the physical geometric horizon at a certain distance, which on the diagram is represented by the red and yellow circle. The physical geometric horizon is the maximum distance that the sea and sky can be observed to meet. This is what is observed. No imaginary other horizon or second horizon where the sky and sea meet can be observed past the line of the geometric horizon represented by the red and yellow circle. Why is there a physical geometric horizon? Obviously, you cannot see around a sphere. Due to the geometric shape of a sphere, there is a specific maximum physical distance an observer can see that is determined by the height of the observer and the size of the sphere. The maximum distance is called the physical geometric horizon. If we live on a physical geometric globe of known circumference with a radius of 6,371 kilometers, 3,959 miles, then the physical geometric horizon, the line where the sea is observed to meet the sky, must be at a specific distance for an observer at a certain height. No imaginary other horizon or second horizon where the sea meets the sky again can be visible past the physical geometric horizon because the physical geometric horizon is where the sea meets the sky. Obviously, on a sphere or globe, the sea is only observed to meet the sky once. What about weather and optics? Misty, foggy, etc. conditions can prevent the observer seeing the physical geometric horizon. The observer no longer sees the physical geometric horizon, represented by the red and yellow circle, but rather an apparent horizon represented by the black and white circle. Apparent meaning seeming real or true, but not necessarily so. This is what is observed. The quality of the optical device being used will determine whether the observer can see the sea meet the sky at the physical geometric horizon. If the optical device does not permit the observer to see the sea meet the sky at the physical geometric horizon, the observer will see a closer apparent horizon instead. This series of observations were carried out between Worthing Pier and Sea Lane Cafe Buoy. The distance, according to Google Earth, is 3.7 kilometers or 2.3 miles. The height of camera lens center ranged from approximately 50 centimeters to 30 centimeters above tide level. For the purpose of the observation, the higher value of 50 centimeters above tide level will be used. The camera used was a Nikon P900. Where is the physical geometric horizon relative to the observer? Based on the Earth being a globe, sphere, with a radius of 6,371 kilometers, 3,959 miles, the physical geometric horizon for the observer at an eye height of half a meter will be 2.5 kilometers or 1.6 miles. Based on Earth being a sphere of a known radius, the physical geometric horizon is 2.5 kilometers or 1.6 miles from the observer. The physical geometric horizon is here, represented by the red and yellow circle. No other horizon or second horizon can be observed past the physical geometric horizon that is 2.5 kilometers or 1.6 miles from the observer. No imaginary other horizon or second horizon can be seen past this point if the Earth is a globe with a radius of 6,371 kilometers or 3,959 miles. Viewing from Worthing Pier to Sea Lane Cafe Buoy. Date 9th of May 2020, Saturday. Time 8 a.m. to 9 a.m. approximately. The Saturday morning observation. Location, Worthing Pier. Worthing Pier aerial view. Location, Sea Lane Cafe, Faring, Worthing. Sea Lane Cafe, Faring, Worthing, bird's eye view, Rocky Groin Breakwater. Locating the buoy, Sea Lane Cafe, Faring. Rocky Groin Breakwater in the distance, Old Groin Breakwater in the foreground. Sea Lane Cafe in the distance behind the Old Groin Breakwater. The buoy, the end of Old Groin Breakwater. Look at the buoy. What kind of buoy is it? This is a cardinal marker buoy. The two black downward pointing arrows warn navigators to stay south, a cardinal direction, of the buoy due to the Old Groin Breakwater, which when submerged poses a threat to boats. An independent YouTube video showing the buoy. Weather information, Saturday, 9th of May 2020. Tide data, Saturday, 9th of May 2020. Low tide on Saturday morning was at 7 a.m. The observations were made between approximately 8 to 9 a.m., during which time the tide was gently rising, as can be seen in the video footage. What do the real-life observations show? Please watch or scan through the following recorded observations. Links will be in the description. What was observed? From observing the video footage, it can be stated: A. No inferior mirage of the buoy was observable. B. No superior mirage of the buoy was observable. C. The tide is gently rising and coming in, gently due to the profile of Worthing Beach. D. The image of the buoy is hazy. E. The yellow color of the buoy is bright. How the video footage will be analyzed. To make the presentation of the observations fair, the following will occur. 1. A video still screenshot will be taken and directly copied and pasted into a PowerPoint slide. 2. The size of the screenshot will not be changed in any way. No vertical or horizontal stretching will occur. 3. A single contrast, saturation, and temperature manipulation will be made to the video still screenshot and be displayed. 4. Video still screenshots will be presented that support the horizon being and not being behind the buoy. 5. Carry out your own watching and manipulation on the video footage. 6. You must decide whether the horizon is behind the buoy or is not behind the buoy. Video still screenshots in support of the horizon being behind the buoy. Video still screenshot taken from video 3, time 3 minutes 34 seconds, supporting evidence for the horizon is behind the buoy. Video still screenshot taken from video 3, time 3 minutes 34 seconds. The horizon is behind the buoy. Manipulation, contrast 70%. The horizon is behind the buoy. Manipulation, saturation 400%. Manipulation, temperature 11,500. Video still screenshots in support of the horizon not being behind the buoy. Video still screenshot taken from video 4, time 4 minutes 15 seconds, supporting evidence for the horizon is not behind the buoy. Video still screenshot taken from video 4, time 4 minutes 15 seconds. The horizon is not behind the buoy. Manipulation, contrast 70%. The horizon is not behind the buoy. Manipulation, saturation 400%. Manipulation, temperature 11,500. You decide, is the horizon behind the buoy or not? Viewing from Worthing Pier to Sea Lane Cafe Buoy. Date, 9th of May 2020. Saturday, time 6 p.m. to 7 p.m. approximately. The Saturday evening observation. The height of camera lens center ranged from approximately 50 centimeters to 40 centimeters above tide level. For the purpose of the observation, the higher value of 50 centimeters above tide level will be used. The camera used was a Nikon P900. Weather information, Saturday, 9th of May 2020. Tide data, Saturday, 9th of May 2020. The final low tide of the Saturday was at 7:30 p.m. The observations were made between approximately 6 to 7 p.m., during which time the tide was gently going out, as can be seen in the videos. What do the real-life observations show? Please watch or scan through the following recorded observations. Links will be in the description. What was observed? From observing the video footage, it can be stated: A. No inferior mirage of the buoy was observable. B. No superior mirage of the buoy was observable. C. Very limited to no distortion is visible. D. The tide is gently going out, gently due to the profile of Worthing Beach. E. The image of the buoy is sharp and clear. Video still screenshots in support of the horizon being behind the buoy. Video still screenshot taken from video 7, time 5 minutes 8 seconds. Supporting evidence for the horizon is behind the buoy. The horizon is behind the buoy. Manipulation contrast 70%. Manipulation saturation 400%. The horizon is behind the buoy. Manipulation temperature 11,500. The horizon is behind the buoy. Video still screenshots in support of the horizon not being behind the buoy. Video still screenshot taken from video 7, time 9 minutes 4 seconds. Supporting evidence for the horizon is not behind the buoy. Manipulation contrast 70%. The horizon is not behind the buoy. Manipulation saturation 400%. The horizon is not behind the buoy. Manipulation temperature 11,500. The horizon is not behind the buoy. You decide, is the horizon behind the buoy or not? Questions from the observations. A number of points arise from the morning and evening observations. 1. The vertical height size of the buoy at full zoom appears to differ between the morning and evening observation. 2. The image of the buoy in the morning observation is hazy and distorted compared to the evening observation. 3. The brightness of the yellow color of the buoy at full zoom appears to differ between the morning and evening observation. The conditions at the time of these observations will now be explored. As can be seen from the two video stills, there is a significant difference in the sharpness of the image and the size of the buoy at full zoom between the morning and evening observations. The vertical height size of the buoy is observably different. Obviously, the size of the buoy itself did not physically change, so what caused the size differences between the two images? What can be factually stated? In the morning, the sun was behind the observer and shining on the buoy and sea in front of the camera. It was brighter during the morning observation, hence the bright yellow color of buoy observed. In the evening, the sun was in front of the camera and shining on the rear of the buoy relative to the camera, causing the side of the buoy facing the camera to be in shadow and the colors to look washed out. The main factors that may have contributed to the difference between the video footage images of the morning observation compared to the evening observation are position of the sun, light intensity, air and sea temperature, rate of water evaporation from the sea, air humidity, air density. No doubt there are others. Since none of the above stated factors were measured, making any statement about the possible effects of them would be an unproven, worthless assumption. It can be stated that the various environmental conditions between the camera and the buoy were the cause of the difference in the images recorded. The atmospheric conditions have caused a vertical height size difference in the image in the two observations. It could be said that the image from the morning observation is compressed relative to the image from the evening observation. Conversely, it can be stated that the image taken in the evening is stretched relative to the image taken in the morning. There are no wrong and right photographs. You may say, well, what should the image and buoy really look like in real life? Which image is the correct representation of the sea, sky, and buoy? Both images are correct for the distance they were taken and the conditions they were taken under. They are exactly what they both should look like. It can only be said that the numerous and variable environmental conditions as well as the workings and quality of the optical device will determine the image observed. To determine that it was the various environmental conditions between the camera and the buoy that were the cause of the difference in the images recorded, another observation was required. What was required was an overcast morning with limited light intensity that could be compared to the Saturday morning observation. Fortunately, Sunday morning was that morning. What follows are the weather conditions and images of the Sunday morning observation. Viewing from Worthing Pier to Sea Lane Cafe Buoy. Date, 10th of May 2020. Day, Sunday. Time, 9:20 a.m. to 10:20 a.m. approximately. The Sunday morning observation. The height of camera lens center ranged from approximately 50 centimeters to 40 centimeters above tide level. For the purpose of the observation, the higher value of 50 centimeters above tide level will be used. The camera used was a Nikon P900. Weather information, Sunday, 10th of May, 2020. Tide data, Sunday, 10th of May, 2020. The first low tide of Sunday was at 7:51 a.m. The observations were made between approximately 9:20 and 10:20 a.m., during which time the tide was rising, as can be seen in the videos. What do the real-life observations show? Please watch or scan through the following recorded observations. Links will be in the description. What was observed? From observing the video footage, it can be stated: A. No inferior mirage of the buoy was observable. B. No superior mirage of the buoy was observable. C. The tide is rising and coming in. D. The image is hazy compared to the Saturday evening footage. And E. The images are clearer than the Saturday morning footage. Video still screenshots in support of the horizon being behind the buoy. Video still screenshot taken from video 12, time 3 minutes 48 seconds. Supporting evidence for the horizon is behind the buoy. The horizon is behind the buoy. Manipulation contrast 70%. The horizon is behind the buoy. Manipulation saturation 400%. Manipulation temperature 11,500. The horizon is behind the buoy. Video still screenshots in support of the horizon not being behind the buoy. Video still screenshot taken from video 10, time 2 minutes 53 seconds, supporting evidence for the horizon is not behind the buoy. The horizon is not behind the buoy. Manipulation contrast 70%. The horizon is not behind the buoy. Manipulation saturation 400%. Manipulation temperature 11,500. The horizon is not behind the buoy. You decide, is the horizon behind the buoy or not? Having two observations from the same location under different environmental conditions allows a comparison to be made. Saturday morning, bright. Sunday morning, overcast. On the left, supporting the horizon is not behind the buoy, and on the right, supporting the horizon is behind the buoy. An image from each observation supporting the horizon being behind the buoy. All images manipulation contrast 70%. An image from each observation supporting the horizon not being behind the buoy. All images manipulation contrast 70%. Conclusion. Have you decided whether the horizon is behind or not behind the buoy? If you have decided that the horizon is not behind the buoy, then you could live on a globe, a plane, or some other geometric shape. If you have decided that the horizon is behind the buoy, then you cannot live on a globe, Earth, with a radius of 6,371 kilometers or 3,959 miles. What about refraction? The word refraction is a term being used in a frivolous way by some people when they talk about a black swan image. This term will be explained and the inaccurate assumptions around its use corrected. You may hear a person say, "On the globe Earth, you can see the horizon behind the buoy because of the refraction of light." A person that makes such a statement is implying that they believe that they live on a globe and that they can see the horizon behind the buoy because light is refracting, curving as it travels, in a downward direction around the curvature of the globe. A visual representation of this statement is shown below. The person making this statement has made a begging the question logical fallacy. What does this mean? This means that for this statement to be validated and taken as being true and factual, first, the person making the claim must prove that they live on a globe if they are stating that light curves around the globe. An example of a begging the question logical fallacy would be a person stating that Fairy's favorite food is chocolate. Before they prove that Fairy's favorite fruit is chocolate, they would first have to prove that fairies exist. If the person cannot prove that fairies exist, then the latter part of their statement is moot. To prove that they live on a globe, the person would have to present empirical evidence based on a method that is repeatable by the majority of people. Pictures, images, or video of a globe Earth are not acceptable. There are pictures and videos of fairies. Also not acceptable are stories of Greeks that supposedly proved things with sticks long ago, computer models, non-equivalent demonstrations, and appeals to consensus and authority. The person must provide a detailed method and with it time and date stamped video footage of the method being carried out. The method can then be scrutinized to examine its validity and repeated and reproduced to determine if comparable results can be obtained. So the person stating refraction, implying they live on a globe, first must prove that their method is valid and not based on logical fallacy. This has not been done yet. If a person could prove that they live on a globe, they would then have to prove that light curves around the curvature of the globe. They would have to prove that certain atmosphere conditions causes the light to usually refract in a downward direction under standard, normal, everyday conditions in a temperate zone country. This is a cause and effect relationship. The density and optical density atmosphere is the cause of the refraction of light, the effect. Being a cause and effect relationship means that this comes under the scientific method. The density, optical density of the atmosphere would be the independent variable, or presumed cause, and the extent that refraction occurs, if at all, would be the dependent variable, or the effect. The person would have to manipulate the density, optical density, of the atmosphere whilst controlling all other relevant variables and visually recording the path of the beams or rays of light. I'm assuming they would use laser beams. The person must provide a method with video footage including dates, times, and locations of it being carried out. The method can then be scrutinized and repeated to check its validity. This has not been done yet. Laser light shows over land and water can be seen on Google Images and YouTube. Check these out and see if you can observe laser light curving in a downward direction. But, the person says, light only refracts in a downward direction gradually over long distances. The person has made a claim. They must now manipulate the optical density of the atmosphere whilst controlling all other relevant variables and visually recording the path of the beams and rays of light. No computer models, fish tank demonstrations, assumptions, logical fallacies, or stories. If they do not carry out the required experiment as described, then their claim is a mere fairy story. Light refraction, the facts. In physics, refraction is the change in direction of a wave passing from one medium to another or from a gradual change in the medium. A ray of light which enters a more dense optical medium at a non-perpendicular angle will refract, change its direction, passing from a less dense optical medium to a more dense optical medium. The light will refract towards the normal, the blue dotted line. The normal line is drawn perpendicular to the new medium. Simply, the direction of travel of the light shifts away from the less dense medium it leaves. Light traveling around a curve. For light to travel around the supposed curve of the Earth, the light would have to continually refract in a downward direction relative to its angle of emission, otherwise it would keep traveling in a straight line and higher into the atmosphere. For light to travel around the supposed curve, the light would have to be continually changing its direction of travel, refracting as represented in the diagram below by the red arrow lines. This is a very simplistic representation. The refraction in this model is assumed to occur continually in a gradual, gentle curving motion over a long distance. This is not assumed to occur at sharp angles like in this image. The validity of this model must be examined. For light to travel around a curve from point A to point B, the light would have to continually refract in a downward direction. For the light to keep refracting in a downward direction, it would be necessary for the atmosphere to keep becoming denser, as shown in the diagram below. 1, the least dense air, to 5, the most dense air. The yellow and black dots indicate light moving from less dense atmosphere to the more dense atmosphere and refracting in a downward direction. The black dotted line indicates the direction the light would have continued to take if refraction had not occurred. The atmosphere is not layered in such vertical sections, so light cannot travel in this manner. But let's go with the model and test its validity further. What would happen if a ray or beam of light was sent in the opposite direction from point B to point A? As the ray of light moves from the more dense atmosphere, non-perpendicularly, into the less dense atmosphere, it would refract in an upward direction and not reach point A. This refraction model can only potentially work in one direction. Real life works in both directions. This vertically layered refraction model has been established to be invalid and wrong. As the previous refraction model has been established to be invalid, the only other refraction model will be examined. In the horizontally layered refraction model, the atmosphere is layered according to density and air pressure. Generally, the densest layer of atmosphere is at the bottom, and the density decreases with height as shown on the diagram below, 1 being the least dense to 5 the most dense. Obviously, due to weather, etc., the layers mix and the density of each layer is variable and changing. A ray of light, example a laser beam, is emitted, released from point A. Point A is only half a meter above the ground. The density of the air changes only very, very gradually with height from the ground for the first 150 meters. The ray of light emitted from point A cannot reach point B by the path shown by the green line. The red ray of light will not refract in a downward direction due to there being no significant atmospheric density difference between half a meter above ground level compared to 1.5 meters above ground level. The necessary refraction required for this horizontally layered refraction model to be tenable cannot happen at the heights and distances presented. The atmospheric density differential is not present. Do you see any refraction in a downward direction? This horizontally layered refraction model has been established to be invalid and erroneous. Refraction summary. The globe, vertically and horizontally layered refraction models have been examined. Through application of Snell's law and the known accepted optical principles of refraction, the globe vertically and horizontally layered refraction models have been established to be invalid and erroneous. If anybody says, on the globe Earth, you can see the horizon behind the buoy because of the refraction of light, then they are choosing to ignore the observable facts and demonstrable principles. If you have decided that the horizon is not behind the buoy, then you could live on a globe or plane or some other geometric shape. If you have decided that the horizon is behind the buoy, then you cannot live on a globe Earth with a radius of 6,371 kilometers, 3,959 miles. My sincere thanks to Karen B. for her technical support in the production, and dedicated to BMLSB69, the original oil rig video footage.